Welcome to Cosmic Compass, where we explore the mysteries of space and time together. From the planets in our backyard to the furthest reaches of the cosmos, we uncover the science, the wonder, and the questions that shape our understanding of the universe. Today, let's set our sights on a fascinating journey, finding out where the solar system truly ends and just how vast a solar system can become. Have you ever wondered where the boundary of our solar system truly lies? Is it simply the orbit of Pluto? Could it be the icy Kuiper Belt? Or does it stretch far, far beyond? Many people have heard that the Voyager spacecraft have already left the solar system since their paths carried them well beyond Pluto's orbit decades ago. But in reality, to say they have left the solar system is not quite accurate. So how do we define the edge of a solar system? And beyond that, how large can solar systems get? Let's start our journey with the Voyagers and see why some say they've crossed the final frontier. The Voyager missions are among the most remarkable stories of space exploration. Launched back in 1977, Voyager 1 and Voyager 2 were built to explore the outer planets. Yet, astonishingly, nearly 5 decades later, both are still operational, though at reduced capacity. Their longevity comes from radioisotope thermoelectric generators, which convert the heat of decaying radioactive material into electricity. But as the fuel decays, power output steadily drops. Today, the spacecraft generate only about half the power they had at launch, forcing engineers to shut down several instruments over the years. Still, the Voyagers continue to send back priceless data. Right now, their most important task is monitoring the magnetic environment of deep space and its interaction with the solar wind. This leads us to a fascinating frontier, the heliopause. The heliopause is the boundary where the sun's magnetic field and solar wind are finally overcome by the interstellar wind, the vast stream of charged particles flowing through the galaxy. Scientists believe Voyager 1 crossed this frontier in 2012, followed by Voyager 2 in 2018, making them the first and only spacecraft to reach interstellar space so far. But what they found was surprising. This boundary isn't a smooth, perfect sphere surrounding the sun. Instead, it's bubbly, distorted, and asymmetrical, much like the way a planet's magnetic field trails off into a long tail under the pressure of the solar wind. The sun itself is moving through the Milky Way at over 800,000 kilometers per hour, and relative to the interstellar medium, this speed is closer to 80,000 kilometers per hour. This creates a kind of wind effect, sculpting the sun's magnetic bubble into a comet-like shape with a long trailing tail. The Voyagers crossing into interstellar space was historic. Yet, as impressive as this milestone is, reaching the heliopause is not the same as reaching the edge of the solar system itself. To define the solar system's true edge, scientists turn to gravity. The concept is called the Hill sphere, the region around a celestial body where its gravitational influence dominates over that of anything else. Take Earth as an example. The Moon orbits Earth because it lies within Earth's Hill sphere, where Earth's pull is stronger than the Sun's. In turn, a spacecraft orbiting the Moon stays there because the Moon's gravity at that distance outweighs Earth's pull. By extension, everything that orbits the Sun from Mercury to the most distant comets exists within the Sun's Hill sphere. This is what we can consider the solar system's true gravitational boundary. But the situation is more complex than a simple sphere. The Hill sphere is distorted by the presence of nearby stars. For example, Alpha Centauri, just over 4 light-years away, is a system of 2 sun-like stars whose combined gravity pulls strongly on their surroundings. This shrinks the Sun's Hill sphere in that direction. On the opposite side, Barnard's star, a small red dwarf 6 light-years away, exerts far less gravitational pull, so the Sun's influence stretches much farther there. Even so, objects orbiting near the boundary face precarious conditions. At such extreme distances, the Sun's gravity is incredibly weak, orbits are sluggish, and the slightest disturbance could eject an object entirely. That's why astronomers estimate that while the Sun's Hill sphere may extend 2-3 light years, stable orbits only exist within about 1 light year. So if you've ever asked where the solar system ends, the gravitational Hill sphere gives us the most scientifically accurate answer. But the story doesn't end there. Beyond the Kuiper Belt and scattered icy worlds lies something even more mysterious, the Oort Cloud. This vast hypothetical shell of icy bodies extends from perhaps 1 light year to as far as 3 light years from the Sun. It is believed to contain billions, perhaps trillions, of icy remnants from the solar system's formation. These are thought to be the birthplace of long-period comets, those that take tens of thousands or even millions of years to complete a single orbit. The scale is staggering. To put it into perspective, even at Voyager 1's incredible speed, it will take about 300 years just to reach the Oort Cloud's inner edge. To pass through it entirely could take anywhere from 30,000 to 150,000 years. And yet all of this, every frozen object, every vast distance, is still considered part of our solar system. When we talk about the solar system being unimaginably large, the Oort Cloud is what we're really describing, a faint ghostly halo that defines the Sun's farthest gravitational reach. Now let's step back and consider a bigger question. How large could a solar system possibly be? For this thought experiment, we'll focus only on stars. Theoretically, the maximum stable mass of a star is around 150 times that of the Sun. Yet even this limit is challenged. The most massive star we currently know, R136A1, is estimated to have about 300 solar masses. However, R136A1 resides in a dense stellar cluster where its gravitational influence competes with that of countless nearby stars. This shrinks the effective size of its Hill sphere. But imagine if such a star were ejected into deep space, far from any neighbouring stars or even galaxies. Isolated with no nearby competitors, its gravitational influence could extend unhindered. Under such conditions, a solar system might span hundreds or even thousands of light years, comparable in size to a small galaxy. In a universe with only 2 objects, a supermassive star and a much smaller companion, that companion could, in theory, orbit billions of light years away and still technically be bound by gravity. After all, gravity never truly stops. It only grows weaker with distance. The only way to escape would be infinite separation, which is impossible. So while our solar system already feels enormous, under the right cosmic circumstances, our solar system could rival entire galaxies in scale. What then is the true edge of the solar system? It depends on the definition. If we mean the end of the Sun's magnetic influence, it is the heliopause, where Voyager 1 and 2 have crossed. If we mean gravitational influence, it is the Hill sphere stretching up to a few light years. If we mean the last icy relics of the Sun's birth, it is the Oort Cloud still awaiting exploration. And yet the deeper truth is that boundaries in space are rarely sharp. They blur and shift depending on how we choose to measure them. Perhaps the most humbling realization is this: in the universe, limits are often illusions. Gravity reaches endlessly. Distances stretch far beyond comprehension. And no matter how far we imagine the edge to be, there is always something waiting beyond it. The solar system reminds us that the cosmos is not neatly boxed, but endlessly vast, inviting us to explore, to wonder, and to keep asking questions. Solar systems are already mind-boggling in size, and under the right circumstances they can be far larger still. The universe is without doubt a fascinating place. If you've enjoyed exploring these cosmic frontiers with us today, consider joining the Cosmic Compass community. By subscribing, sharing, or supporting the channel, you help us bring more journeys like this to life. Until next time, stay curious, and let's keep navigating the wonders of the cosmos together. Thank you for joining us on this cosmic journey. If you enjoyed this exploration and want to keep traveling through the stars with us, don't forget to subscribe and share this video. It helps us chart even bigger adventures. And remember, in the endless expanse of the universe, every question we ask brings us one step closer to understanding. So let's keep wondering, keep exploring, and keep following the cosmic compass. Until next time, safe travels through the stars.